Hello, we are doing Unit 8 Statistics, Lesson number 8 on applying center of variability. Your objective is to apply appropriate measures of center and variation to represent a data set. Let's review. So when we're talking about the shape of a graph, we have symmetrical or skewed. So here I've attached a visual to give you the difference between symmetrical, skewed right and left, a symmetrical U-shaped, and a uniform for histograms and dot plots. And then the one on the far end is called a box and whisker plot or a box plot, and we'll be discussing those in tomorrow's lesson. So our symmetrical data, the mean is in the center where that high point is of the graph, and therefore it shows where the data is, but it's not always a true representation of the data, but it is the best way to describe the center of that data. Where we have a skewed, our median is closer to that center, that high point where the mode is, and therefore the median is a better way to describe the data when you have a skewed data. It might not always be an exact value because remember, if we have an even number, we have to find that middle value. And it doesn't always have to be the middle of the ranges of those values as well. When discussing the variability or the spread of the data, when you're talking about a graph that's symmetrical, the mean absolute deviation is the best way to describe that variation. Remember the MAD, if it's close to 0, it's closer to the center or the mean. When you're looking at a skewed data, the interquartile range is the best way to describe the variation, as it talks about the spread around the median. And remember, the smaller the IQR, the closer that data is to the median. The bigger it's, the larger the spread of that data. When graphing, you can use any graph to represent data. But when you're looking at something that's symmetrical, a histogram or a dot plot is a better way to go because you can see that center and how everything's clustered around the center. Whereas skewed, a box plot is a little bit better because the whiskers show you that spread and the box shows you how that data is related to the median, which is close to that center. So a study was conducted of 2 different banks and the wait time in line for customers and how long they had to wait. We're going to describe the meaning of this data, and then we are going to determine which bank would you rather stand in line for and why. Mean, the average for both banks is the same, 8. So that doesn't give me enough information to determine which bank has a better wait line time. When I look at the MAD, the mean absolute deviation, remember that means the distance from the mean. It's talking about how spread out that data is. So I can either add or subtract the MAD from the mean. And when I do that, I get either 2 to 14 at statewide bank. And when I do that for the national bank, I get 7 to 9. So I can see that statewide bank, I could be waiting in line for 2 minutes, or I could be waiting in line for up to 14 minutes. And national bank, I can wait in line between 7 and 9 minutes in general. So when I look at the MAD, I'm going to say national bank is better because they're more consistent. The data, majority of the people are waiting around 8 minutes, where the MAD, it's spread out. So it can vary greatly. Citibank is a new bank in town, and they're advertising that they have quick lines to satisfy their busy customers because they want to draw in new customers. And we are going to compare Citibank to National Bank. So I'm going to take this data and I'm going to make a graph. And you can make a histogram, a dot plot, a box and whisker plot. But I'm going to go ahead and just do a dot plot. And I can see that my national bank has a somewhat symmetrical bell curve, and my Citibank has somewhat of a little skewed bell curve. I already went ahead and calculated a mean, median, mode, MAD, and IQR. So remember the mean, you add up all your data points and divide by how many data points you have. And when I did that, I got 8 minutes for National Bank and 6 minutes from Citibank. So Citibank has, on average, 2 minutes less wait time. Then I went ahead and calculated the median. So that's taking that middle data information, and I got 8 minutes for National Bank and 5 minutes for Citibank. So again, Citibank's looking pretty good. For mode, I can easily just look on my graph which one has the most dots, and I can see that we got 8 minutes again for National Bank and 5 minutes for Citibank. Now, for calculating the MAD or the IQR, you don't have to do both because they're both talking about the spread. And so you only really need one, but I went ahead and did both of them. And remember, the mean absolute deviation is taking that absolute value difference, that data point that it is from the mean. So by subtracting the mean, and then you add up those new points and take that mean, and when I did that, I got 9/10, which is pretty close to 0 for National Bank, and I got a 2 for Citibank. So that means the spread is much larger. And if I were to add or subtract 2 minutes to 6, that means we have an average of 4 to 8 minute wait time. Whereas National Bank, we have a 7 to a little less than 7, I mean a little more than 7, a little less than 9 minutes wait time for National Bank. And then you can see I also did the IQR. It's less math, and you're just taking the mean of the lower quartile and upper quartile. And remember, IQR is quartile 3 minus quartile 1. And when I did that, I got 1.5 or 4.5. So again, I can see that the spread is bigger for Citibank. So to answer the actual question, does Citibank live up to the advertisement? Well, the mean is 6 minutes, so yes. The average customer waits 2 minutes less. However, National Bank is more consistent than Citibank. We have finished another lesson, and now you're off to Khan Academy and your IXL practice. Please make sure to do your exit ticket in the Google Classroom before moving on to lesson number 9. And if you have any questions throughout this time, please make sure to put that in the discussion page. And thank you for watching.